this video, I want to show you how to replace the front strut assembly on this Ford F-150. Let's get started. Let's remove the wheel. You would want to use a 21mm socket. If your lug nuts are swollen like mine, because underneath the chrome cap it rusted, you would want to use a 22. And remove the wheel. Now with the wheel off from the back side, you can see the caliper that we have to remove. There's also a vacuum hose here for the hub actuator. I'm going to want to pull that off the hub, so let's do that now. We need to get as much stuff out as possible to have room to bring the knuckle forward so we can get this axle out. If you have to, you can use a screwdriver, a pry bar, to help pry this up and off, just like that. Then with a 10mm socket, remove the retainer bolt for the bracket that holds the brake hose on. Pull this out of the knuckle and set it aside, and unclip the ABS wire from this. Let's also unbolt the ABS wire from the knuckle with an 8mm socket. If it feels like it's going to break, work it back and forth because you don't want this breaking inside the knuckle. I've already done this, but I'm going to spray it again with a bunch of rust penetrant. Hopefully that'll work its way in there and help me loosen this up a little bit easier and without breaking it. There it is. Pull this off. Follow the ABS wire up and unclip it from where it's secured onto the frame. Just like this. Follow it up even more. It's clipped right here next to the control arm. Remove it from this retainer as well. I'm going to follow the ABS sensor all the way up here on the fender liner and unplug it. There's a clip on the back side. Press it and slide it out of its connector. Okay, just pop it out. Oh, there we go. That's why it's not coming out. A lot of times these get pretty full of debris here. Now you can pull the wire down. Now have a bungee cord ready so you can tie the caliper and bracket assembly out of the way. We're taking off the whole thing as a unit. Take this 18mm bolt out, as well as this one down here. Those will take off the caliper bracket off of the knuckle directly. With one off, leave it on a few threads so that you can have the caliper supported while you take off the other one. Now take both off. Pull it off of the rotor. Remove caliper and bracket assembly out of the way. We're taking off the whole thing as a unit. Take this 18mm bolt out, as well as this one down here. Those will take off the caliper bracket off of the knuckle directly. With one off, leave it on a few threads so that you can have the caliper supported while you take off the other one. Now take both off. Pull it off of the rotor. Remove your rotor. If yours is stuck on because of rust, mine's not because it's new. But if it is and you're reusing it, then tap between the lug studs. That should break it free off the hub, but just make sure you don't damage the studs. Now we have to get this cap off that hides the axle nut. So take a screwdriver or a pry bar, tap it in here. There we go. Now you should be able to just pry it off of here. Then take a 13mm socket and let's remove the axle nut. At this point, you want to make sure the axle pushes through, which it does, so that's perfect. Next, I want to unbolt the outer tie rod stud off of the knuckle. To do that, you can use a 21mm socket. Now take a hammer and tap the knuckle right here so the tie rod stud can break free. There we go. Remove the tie rod from the knuckle. Now let's disconnect the upper ball joint from the knuckle also so we can tilt the knuckle forward. Use a 21mm socket. Put the nut. Now we have to get this cap off. So take a screwdriver or a pry bar, tap it in here. There we go. Now you should be able to just pry it off of here. Then take a 13mm socket and let's remove the axle nut. At this point, you want to make sure the axle pushes through, which it does, so that's perfect. Next, I want to unbolt the outer tie rod stud off of the knuckle. To do that, you can use a 21mm socket. Now take a hammer and tap the knuckle right here so the tie rod stud can break free. There we go. Remove the tie rod from the knuckle. Now let's disconnect the upper ball joint from the knuckle also so we can tilt the knuckle forward. Use a 21mm socket. Put the nut back on a few threads to hold the knuckle as you break this free. And just like we did for the tie rod, hit the knuckle right here and it should pop off. There we go. Pry the control arm down, take the nut off, pull this up, and the knuckle will come forward. Now get the knuckle off of that upper ball joint, pull it forward, and there you go. Use a 30mm socket on the nut side and a 27 on the bolt side to hold it. Break this nut free. They're very tight, just as a little disclaimer. Take that off and make sure the bolt spins. If it doesn't, it's most likely seized inside the bushing there. So spray some rust penetrant and try to twist it back and forth. Fortunately for us, this one is not seized. Take a hammer, hammer the bolt out. Take it out the other side. At this point, let's take a pry bar, pry the control arm down and the strut out. The control arm might not want to go down all the way because the sway bar is still attached, but that's okay, at least this broke free. Now to get more swing out of the lower control arm, I'm going to disconnect the top of the sway bar link here, use an 18mm socket, and we might not be able to take the nut off all the way with this, but I'm going to try it out. If it doesn't work, we'll hold this with pliers or a wrench and then use a wrench on this. At this point, the nut actually came up more than I expected. And because there's a large washer here, this allows us to put some locking pliers on without damaging the boot. Lock these on tight and finish removing the nut. This will hold the stud from spinning. There we go. If that doesn't work for you, just try to work it back and forth with rust penetrant. Eventually, it will come off. The top of the sway bar link here, use an 18mm socket, and we might not be able to take the nut off all the way with this, but I'm going to try it out. If it doesn't work, we'll hold this with pliers or a wrench and then use a wrench on this. At this point, the nut actually came up more than I expected, and because there's a large washer here, this allows us to put some locking pliers on without damaging the boot. Lock these on tight and finish removing the nut. This will hold the stud from spinning. There we go. If that doesn't work for you, just try to work it back and forth with rust penetrant. Eventually, it will come off. Take these off, and now we can swing this lower control arm down even more. I'm going to bring this axle back over the sway bar so it can be held here. If you need to tie it with a bungee cord, go ahead and do that. You just don't want it to swing down too far. Pry the shock up, or the strut, and the control arm down. Okay, there we go. Now the strut is free, so let's unbolt it off the top. At the top of the strut tower here, you'll see 3 15mm nuts that look like this. There's one here, and one in the back that is a little bit harder to see, but you can reach it. Just go over these lines and hoses. Take your 15mm socket. Sometimes you'll have to hammer it on here just because of rust buildup. And they are fairly tight, so make sure you have a long ratchet or a breaker bar of some sort. Try to break these free. There we go. This one, I'm going to back off a few threads, but I'm going to leave it on. I want to leave this one on for last because I want it to be accessible when the strut comes down, so I can leave this connected without it falling off, and then I'll unthread it the rest of the way when I'm ready to remove it. Move on to the second one. Take this one all the way off. And the one in the back you'll need a deep socket for, unless you want to pop these lines off. They just have a connector here, but I'm going to leave them on. Just put my socket over, break it free. Okay, this one's off, so this is the only thing holding the strut in at this point. I'll leave it on like this. Okay, once you pry it out, remove the last mounting nut. And now you can pull the strut right down and out, and there it is. Take your new strut, line it up at the top. It should slide into place. Have a mounting nut ready because it's pretty heavy, and thread this on just so it can hold it in place. If you line it up at the top and it does not line up at the bottom, which as you can see for me it does, that just means you have it backwards. So rotate it 180 degrees and then both ends should line up perfectly. Now put on the rest of the mounting nuts. We'll bottom them out, and the torque for these is 30 foot-pounds. I have a pole jack underneath the lower control arm so I can raise this up. I'm not going to be able to just lift it up by myself. So I'm going to put upwards pressure on it. As I do that, make sure that the sway bar link goes in through the sway bar. Otherwise, if it doesn't, it stays like this. You'll have a lot of trouble getting it in once the control arm is up. Also, the lower part of the strut is in the control arm, but it's not lined up yet. So as the control arm goes up, just make sure it lines up with the bolt hole. Okay. Pry this whichever way necessary to line it up. My bolt hole is very close to being lined up, so I'm going to go up a little more, get this lined up with that hole. I'm going to hold my pry bar here. I have my bolt ready, stick it through. On this side, the bolt needs to pivot inward like that. So what I'm going to do to get that lined up, I'm just going to take my socket with a breaker bar so I have some leverage and use that to basically pivot the bolt. Sway bar link is still lined up and on track to going in through the sway bar. So I'm going to raise this up a little bit more. With pressure still upwards on this control arm, I want to get this as close as possible to ride height so I can tighten this bushing without putting it in a bind when the truck is sitting on the ground on its own wheels. So put the nut on, let's snug it up, and the torque for this is actually 406 foot-pounds. But what I'm going to do, because I don't have a torque wrench that goes that high, is I'm just going to use my air gun and make it nice and tight. Hold it in place and tighten it up. There you have it. Take a pry bar and pry the sway bar down onto the sway bar link, just like that. Put the mounting nut back on, and let's tighten it up. 59 foot-pounds is the torque for this. There we go. Now with the lower control arm supported and pressure on the strut, let's torque this to 30 foot-pounds. If you don't have a torque wrench that'll fit in here, just make sure it's nice and tight by hand. It's about a quarter of a turn after it bottoms out. Okay, all three are torqued. At this point, I want to bring the knuckle up, make sure the axle actually slides through here. As you bring the knuckle up, make sure the upper ball joint on the control arm lines up. Looks like I'll need a pry bar to pry this down enough. Have the upper ball joint nut ready. Stick the pry bar in between the spring here. Okay, once you get it close enough, put the nut on. Take your 21mm socket, pry down on the ball joint, and snug this up. The torque for this is 85 foot-pounds. The knuckle will spin because the tie rod's not connected yet, but once it bottoms out, you'll be able to torque it. That's 85 right there. Plug in the vacuum hose for the hub actuator. Make sure it's bottomed out completely. Let's get the tie rod stud back in. Press it down all the way into the knuckle, put the nut on, and we'll torque this to 85 foot-pounds. Here. Okay, all three are torqued. At this point, I want to bring the knuckle up, make sure the axle actually slides through here. As you bring the knuckle up, make sure the upper ball joint on the control arm lines up. Looks like I'll need a pry bar to pry this down enough. Have the upper ball joint nut ready. Stick the pry bar in between the spring here. Okay, once you get it close enough, put the nut on, take your 21mm socket, pry down on the ball joint, and snug this up. The torque for this is 85 foot-pounds. The knuckle will spin because the tie rod's not connected yet, but once it bottoms out, you'll be able to torque it. That's 85 right there. Plug in the vacuum hose for the hub actuator. Make sure it's bottomed out completely. Let's get the tie rod stud back in. Press it down all the way into the knuckle, put the nut on, and we'll torque this to 85 foot-pounds. Put the axle nut on. We'll torque this to 20 foot-pounds after we bottom it out. It's easy to hold the hub at such a low torque. If you can't, just put a pry bar in between. Make sure it's on the flat side so it doesn't damage the threads, and hold the hub from spinning by the pry bar. Put this cap back on. I like to put some grease around the ring here. If you want to put RTV, you can. Tap it in with a rubber mallet. Make sure it's nicely seated. I have a new hub here. If you still have your old one, go ahead and clean it up so that these two ridges right here are nice and smooth. There's no buildup, no rust, no debris on them. And then we'll go ahead and coat them with Inices. And I will do that regardless of whether it's a new or an old hub. I also have a new rotor. If you don't have a new rotor, make sure the backside is clean, nice and smooth. There's no buildup, no rust, no debris on them. And then we'll go ahead and coat them with Inices. And I will do that regardless of whether it's a new or an old hub. I also have a new rotor. If you don't have a new rotor, make sure the backside is clean like this one. Sand it down if necessary. Make sure you don't take off too much material though. And then slide it on. It's important that these two sit perfectly flat up against each other. And to secure this, I'm going to use a lug nut to clamp it on. You don't have to make this very tight. Just put it on here by hand so it can hold the rotor and prevent it from falling off. If it falls off and rust gets behind here, it'll sit crooked once it finally gets tightened down. And then you'll have some issues driving down the road, especially at higher speeds. Now let's get the caliper over the rotor. Slide it on. Start in the two caliper bolts. Bottom these out and then torque them. The torque for these two is 136 foot-pounds. Let's get these reconnected. These brackets here, I'll start with the brake hose. Put this back on. This is the 10mm bolt that held it into the knuckle. Nice and snug, about 1/8 of a turn after it's bottomed out. Start the ABS wire in. Okay, bottom that out, make sure it's snug. Over here, clip this into the brake hose retainer. Follow the ABS wire and clip this into this bracket over here. Run it behind this brake line. There was one more retainer for it. That has to clip in right over here next to the vacuum hose. And the last part is to plug it in. Make sure that clicks and secure the connector onto the fender liner right there. Let's get the wheel on. Start on all 6 of your lug nuts, bottom them out, and torque them to 150 foot-pounds in a cross pattern. There you have it. Take it for a road test. After finishing this repair, it's important to have an alignment done on your vehicle.
When only the best will do, demand TRQ. The only company that lets you view before you do. TRQ is committed to offering the highest quality aftermarket auto parts that are engineered for peace of mind. Thanks for using and viewing with TRQ.
Saving money feels right. Just like when things packed tidy and tight. Get auto insurance that fits your budget and your needs. Save up to 10% when you bundle auto and renter's insurance. Get a quote today.
In this video, I'm going to show you how to replace the valve cover on this Ford F-150. In our case, we're working on the 5.4 liter 3-valve V8. Let's get started. To get started on this valve cover replacement, we have to get the intake tubing out of the way. Right by the air filter housing next to the mass airflow sensor, there's going to be a clamp. Loosen it up with an 8mm socket or a flathead screwdriver. Don't remove it, just loosen it. And right by the throttle body, there will be another one, same size. With this loosened up, you can now pull the intake tubing out of the way and set it aside. Now let's disconnect the PCV hose that clips on to the top of the valve cover here. All you have to do this is pry this little gray clip out and down. That unlocks the hose, or the fitting for the hose, and you can pull this up and move it out of the way. You can't really see it, I can't see it either, but if you follow the hose on the back side, there will be a clip just like this one. If you unclip it, you can pull this out and set it completely aside so that it's not hanging over where we're gonna work. Next, I want to unplug everything so I can move this harness aside. Just start in the front, unplug all of the ignition coils, as well as the injectors, so that you can have as much slack in the harness as possible. And now, as you can see, the harness is clipped in here and here onto some studs. Ignore this wire. You should not have this. This is because this truck has a remote starter attached to it and someone has tapped into the injector harness. Technically, it should not have that. To remove the harness off of the two retainers here, you just pull up on it, wiggle it. If that doesn't work, we might have to get a trim tool, but it looks like it does work. Be careful of this tube right here, this pipe, which is actually a vacuum supply to the brake booster. Looks like it's bolted on to the stud that holds on this harness. So there we go. There's that. At the front, this is clipped into the valve cover. Pop this out. There's another connector right here at the front on the timing cover that you can unplug. And I should have done this earlier, but I didn't realize that it would actually be useful. I'm going to unclip this connector here. This is just a ground. This is just a ground for this harness. Take a pocket screwdriver, pry the tab up. Well, it has to come out of here first, and then pry this tab up and pull the connector out. Even though you might have enough slack with it just unhooked from the harness, disconnecting this will provide a wide open space for the valve cover to swing out of here. There we go. Now we can get this wiring harness pulled this way. This can be out of the way there. Now that we have the harness out of the way, if you have a lot of debris like I do here, there's a lot of sand buildup and some leaves, I'm going to vacuum it. I recommend you do the same. If that's the case for you, you can also use some compressed air and blow it out, but you want to get rid of it not only because of the ignition coils, you don't want anything falling in the spark plug tube holes, but you also don't want any debris along the valve cover where it meets the head, so that once we pull the valve cover off, there isn't a possibility of sand getting inside the head. Now use a 7mm socket and remove all of the mounting bolts for the ignition coils. Pull these up. Okay, so I moved this harness up. I was able to just maneuver it out of the way. Regardless of whether you have it hanging on this side or that side, it doesn't matter. This was just more out of the way for me. At this point, there are a bunch of 8mm bolts running around the whole valve cover. We have to unbolt them all, but keep in mind they won't come out. They do stay in the valve cover. Once you unthread them, they will just keep spinning and spinning in place without actually coming out. So Having said that, I'm just going to go around and unbolt them all. I'm going to start at the rear just because I want to get the more difficult ones over with, and then I'll work my way towards the front. For these bottom ones, you can go through the wheel well. You do not have to remove the wheel or the fender liner for this. There should be plenty of room. For this one, you either have to do it by hand or with a swivel because of the steering shaft. And then, most likely, we're gonna have to unbolt the oil dipstick tube so that we can pull it away from the next bolt. I don't necessarily recommend bending it out of the way because you can permanently damage it, especially when it's rusty like this one. And if it breaks, you'll have to replace it. The bolt for the dipstick tube is also an 8mm. You don't have to take this bolt all the way out. I will, but if you just want to pull the dipstick away at this point, you can. Okay, now we can pull this back like this. I'm actually just going to take a bungee cord, tie it this way, probably up against the upper control arm or something, just so I can have it pulled and held this way. Now you can get to this one. That was right next to the dipstick tube. Since I'm working down here, I might as well continue. And that should be all of them. At this point, all that's holding this valve cover on is going to be the gasket itself from being partially stuck on there most likely. And then keep in mind that this solenoid has a grommet around it, so this is going to be a little bit stuck on here. We'll have to work it up and off of that solenoid. You can grab the valve cover if you have to. You can gently pry it. Just make sure you don't pry in areas that shouldn't be pried on, such as against the plastic intake, up against any sensors or anything like that. I'm going to go right here on the corner of the head where it meets the valve cover. You can see it pops right off. In the back, unfortunately, it's very limited on space, so there isn't a lot of space to pry. You might be able to get a little screwdriver or a very small pry bar in there, but usually once you get it broken free off the front, you can just grab it and lift it. This vacuum hose is going to be still on here, so try and lift it up and off. There we go. Wiggle this off. It should have enough slack in it to move out of the way. And you can grab the valve cover, slide it right up and out. And there it is. In my case, the gasket stayed on the engine side. It doesn't usually happen, but this is actually a good thing because now I can take the vacuum cleaner and suck up all this sand that is still left on here from when the valve cover was on. As you can see, there's quite a bit of debris, and the gasket is acting more like a dam, a barrier, to prevent that from going in the engine, so it worked out in my case. And now if this is the case for you also, peel the valve cover gasket off of the engine block. If not, it's most likely going to still be on the valve cover, in which case you'd remove it from there. And there you have it. Now if you had your new valve cover, you'd take your brand new gasket and line it up with the valve cover, place it on. Now I always recommend doing both sides at a time. And when you do this, obviously you'll get both side gaskets in one package, but it's not difficult to figure out which one is which because the other side will not fit on, well, its wrong side because it's a mirror image of each other. So all of these loops you'll have on the opposite side. And this gasket only fits down one way, has a flat side on one side and a pointy side on the other side. So like I said, once you lay them on the valve cover, it's easy to figure out which is which. Make sure that you press this in all the way around. You want this fully seated on the valve cover, and it should basically lock into place, press itself down, just like that. Perfect. One other note I'd like to put out there is the fact that you may have to transfer over your bolts to the new valve cover unless they already come with them, in which case they would also come with new gaskets. If not, here's how you remove them. Well, all you have to do is just wiggle them while pulling out, and they should pop out. And if you need to, I'm going to show you how to replace these grommets. Let's replace the grommets for these studs and the 2 bolts that are on this valve cover. The way to do that is you want to take a razor blade and cut right down the middle, just like this. Once you have it cut, split it open, peel it off. This is the easiest way to get these off. Take the grommet, make sure it's facing with the larger part towards the larger seat here. Put it up against the stud, spray some brake parts cleaner in here just a little bit. The reason I do that is because it lubricates it, but it does dry up really quickly after it's installed, so I don't have to worry about this soaking in oil for a long time and potentially swelling up. As you can see, the brake parts cleaner is already dry, and it made it so that I can slide the grommet on with ease. The clip I just showed you was actually from a different valve cover, but they have the same exact bolts and grommets. Mine are good, so I'm going to reuse them. They are still soft and malleable. If they are stiff and they don't squish anymore, you're going to want to replace them, of course. There are 2 things I wanted to mention before we continue with reinstalling the valve cover. This is one, you'll see RTV on the corner, on both corners, top and bottom, where the timing cover meets the head. We have to scrape this off and reapply new RTV because this split right here can and will cause an oil leak if you don't reapply it. The best way to get rid of that RTV is with a razor blade. Try not to scrape towards the inside of the head. I'm going to pick this larger piece off by hand, and then with a razor blade, I'm going to come in and scrape upwards. That way I push all of this debris away from the engine. If you wanted to run the vacuum cleaner while you're scraping, that would also be a good idea, and it'll basically catch everything that you're scraping. Okay, it doesn't have to be perfect. Just get the larger chunks off. Then I'm just going to go around, make sure the rest of the surface is ready to go. There will be another spot just like this one on the bottom, on the other side of this timing chain and cam sprocket, so make sure you scrape that as well. Now before we apply the RTV, after this area has been cleaned, I'm going to take a rag with brake parts cleaner on it and just degrease it. I'm actually going to go around the whole head surface where the valve cover goes on and do this, but it's very important to do it here so that the RTV can actually seal up properly and bond to the surface. Ideally, I would use black RTV, which is meant for oil. This gray stuff is for high torque applications, but it also is very oil resistant, and if this is all you have, unfortunately this is all I have at the moment, this works as well. Apply a little bit over here. I actually might have applied a little too much, so I'm going to remove some with a gloved finger. If you put too much, it'll just squeeze out and into the head. You want to try to avoid that. And we're going to do the same down here on the other side, where the valve cover also needs to seal up properly. Try and make it as even and smooth as possible. Now make sure everything is cleaned up. As you can see, I degreased this surface, so let's bring the valve cover over. Now let's bring the valve cover in. Try not to shake debris from other hoses and components here inside the engine. Slide it over gently so that the valve cover gasket does not get pinched or torn or actually removed, popped out of the valve cover itself. You want it to stay seated right where you put it. And the most challenging part here is going to be getting it over all the way onto the back of the head. There we go. That just seated itself perfectly in position. Right here, it's seated over the solenoid. All of the bolts line up. I'm going to start some of them in. That way I'm sure that it is perfectly lined up with all of the threads. There we go. This one just started in. I'm going to go around, start all of them, and then we will come back and snug them and torque them in the proper sequence. There is a sequence for this, keep that in mind. But before I do anything with that, I'm going to make sure that they're all actually lined up. And the more of them you start in, the higher of a chance you have of it being perfectly lined up for the rest of them. Okay, that's all of them. I'm going to put this vacuum hose over the valve cover, over the stud. That way this is back in place and secured, well, temporarily. And now let's go around and bottom these out slowly. I don't want to completely crush this gasket here. I just want to bottom it out, get it close to the torque spec, which we will go over in a second. But for now, I'm going to go from the middle, working my way out. And now with all of these started, let's go from the center out and bottom them out. Then we will come back and torque them. The torque for this is 89 inch-pounds, so it's not a lot. So when you bottom these out, just make them snug. Once again, 89 inch-pounds. That converts to 7.4 foot-pounds in the same sequence, starting from the center, top bolt, going down, and working your way towards the outside, going in sort of a crisscross pattern. If you don't have a torque wrench that goes that low, and you don't have the ability to torque it, just make it nice and snug with a ratchet or a wrench, whatever you're using. Make sure it's even all the way around. That's what's most important here, so that the gasket can seal up all the way. That's all of them. I'm gonna go back around one more time, because with rubber gaskets like this, as you tighten the last few, the first few will want to loosen up just because the gasket squishes, compresses, and allows for more wiggle room and more slack in the bolt, basically. It might not always happen, but it does sometimes, so you always wanna double check. All right, these are all tightened down, so now let's just put everything else back together. And now with this bolt started, let's just bottom it out. The torque for this is 89 inch-pounds, but I cannot fit a torque wrench in here, so I'm just going to make it nice and snug with my ratchet. 89 inch-pounds is not a lot. It's basically just at most an eighth of a turn after it's bottomed out. So make it nice and snug. Just be careful because it is a very small bolt. You don't want to break it or strip the threads. Getting close, that's bottomed out. An eighth of a turn, done. That's all I'm going to do. Let's get the ignition coils back in. Slide them all down. I like to put them back from the cylinder that they came from. You don't necessarily have to do that. And now put the mounting bolts back in. And snug them up. You don't have to make these very tight, just bottom them out and make sure they're snug. Let's bring the harness back over, plug everything in. Doesn't really matter where you start as long as everything gets plugged in and re-secured. Make sure all of the connectors click. If it's not audible, make sure you at least feel it click. And re-secure this harness on those two studs. At the front of the engine, re-secure the harness over here. If you unplugged this connector, reconnect it. Get the PCV hose reconnected. Make sure you snap it down all the way, and you should see this clip lock in. Do the same on the back side. On the intake, it's a little more difficult to see, but if you feel for it, you should, there we go, feel it snap in place. Perfect. Double check all of your electrical connectors. If the injectors or ignition coils are not properly plugged in, or there's an issue with the wiring, you will have a misfire and the truck will not run properly. So it's important that you double check all of this. Everything else is secured. Let's put the intake tubing back. Make sure that it's seated on both ends. Now snug up the clamps. When tightening, I like to tighten them by hand so that I can feel how tight they're getting. I don't want to accidentally break it or strip it out. In that case, I would have to replace it. Just give it a couple turns at most after it has snugged up. Okay, that should be good right there. What you're looking for is when you move this intake tube, it shouldn't move on the part that's connected. It should just flex a little bit, but this should stay put. And there you have it, job is complete. I always recommend an oil change after replacing the valve cover gasket or having the valve cover off for any other reason. The only thing with that is you want to run the engine, run it for about 10 minutes so that any debris that may have made its way inside there can be flushed into the engine, picked up by the oil filter, and then you can change it out for fresh, brand new oil. Having said that, double check all of your electrical connectors if for some reason the engine doesn't run properly, and then take it for a road test.
When only the best will do, demand TRQ. The only company that lets you view before you do. TRQ is committed to offering the highest quality aftermarket auto parts that are engineered for peace of mind. Thanks for using and viewing with TRQ.
At Harbor Freight, we do business differently from the other guys. We design and test our own tools and sell them directly to you. No middleman, just quality tools you can trust at prices you'll love.
Howdy folks, welcome back. Got us another broken Ford truck to play around with. This is a 2005 Ford F-150. It's got the 3-valve Triton hand grenade under the hood. Change engine light is on. It's definitely got a misfire. I can hear it's got the classic Ford cam phaser death rattle on startup. I believe it's been to another shop. Supposedly it's had spark plugs and coils installed. It's got a laundry list of DTCs stored in the computer, so I think this is going to be a good one. Okay, I'll let the Autel do its thing. So it's got 9 DTCs stored in the PCM, which is not good. So we got timing codes, looks like intake camshaft over retarded, lean on bank 1, and then multiple misfire codes 3, 5, 7. Misfire on first 1,000 revolutions, cam position sensor, wow, ignition coil primary secondary, and then there's a bunch of ABS stuff that we probably aren't going to worry about, and stuff for the transfer case, integrated wheel end circuit solenoid, so we're not going to worry about that for right now. We're working on the engine. We got to figure out what's going on. So I don't know if it's out of time or we got a bad cam sensor or crank sensor. Hello family. What are we doing?
Somebody wanted to come visit you, so I tagged along.
Hi kiddo. Are you gonna get all Dad's tools out? That's the sharpest one. Can you put that back please? Yeah, but 3-year-olds don't need to hold wood chisels.
What about this thing?
That's a stud finder. How about the pliers? You want to play with pliers?
Yep, they're
Okay.
super sharp.
Yeah, so be careful with them. Well, the fuel trims aren't great, but they don't look like they're totally out of whack. I don't know why that long-term fuel trim is so high. Definitely got some mechanical noise over here. This side. Yeah, I'm saying there's no way those coils have been replaced either. I can't find misfire counters on the Autel for this Ford, so I'm just going to generic OBD2, the mode 6 data. So it looks like cylinder number 3 is our main problem. Well, 5 and 7 have a little bit, but yeah, cylinder 3 seems to be the bad one. Alright, this is a Ford, so it should be 1, 2, 3, 4 on this bank. So if I come down here, I should be able to unplug the coil. I don't hear it change, do you? Let's try 2. Oh yeah. Okay, so we're definitely dead on cylinder 3. So this should be 5 right here. Oh yeah, makes a big difference. And then 7 back here. Okay, so let's worry about number 3 for right now. Well, I don't know. The customer told me that he had the coils replaced. He said they replaced the coils, the boots, and the plugs. I don't know who they are, and I don't know any more details than that, but these sure look like factory coils to me. They've got the paint marks on them still. This one here, cylinder number 1, I think maybe has been replaced. It looks different than the others. But the other 7 coils all look the same. They all have the same part number, so I don't think there's any way that they've changed those coils out. So I guess maybe the easiest thing to do right now would be to switch the coil from 3 to 2 and see if our misfire moves with the coil. Well, before we go pulling coils and doing the switcheroo, I think it's time to play around with the new toy. This is a 4-channel picoscope. It's the automotive variety. I bought this brand new from AES Wave. So here's our scope unit right here, 4-channel. They came out with a new model 4425 or 4225, whatever this is. They came out with a new one that has the smart probes so that when you connect them they automatically detect. I don't need that, so I bought the old model, which is now slightly discounted. So it was a good time to buy it, I think. I've needed one for a long time. I've just been putting it off because it's, you know, a big chunk of change. So it comes with a little selection of back probes and, I don't know, regular probes and clamps and an attenuator. I think this is probably broken now. Yeah, it's a 10-to-1 attenuator. So that's good. This is our USB cable that should hook up to our PC. So this is a secondary ignition test lead. So if you have a vehicle that has spark plug wires, you can clip this around the spark plug wire. And I believe it's a capacitive pickup. And then 4 test leads, 1 for each channel. So that's all in that box. And then in this box, this is an extension lead for a coil on plug ignition. So you would plug this into the coil and then plug this end onto your spark plug, and then you can use that secondary ignition probe to measure your secondary ignition waveforms just like you could with the normal, you know, distributor system where it has spark plug wires. Comes with a ground lead. So I also ordered a paddle probe for the coil on plug ignition. That's supposed to be here maybe tomorrow. And then I ordered some various adapters for BNC to banana jack and whatnot. And then I tried to order the U-test kit, which is all the test leads, but I guess it's on some kind of indefinite back order. So I don't know what's going on. AES Wave's got a lot of stuff on back order right now. It must be stuff coming out of China and they're having trouble getting it because of the coronavirus or something like that, or I don't know what their supply chain is, but for whatever reason you can't get a lot of stuff right now. Okay, here's a wiring diagram for this coil unplug ignition system. So you got a hot at all times, goes through a 20 amp fuse, through the ignition switch, back into the junction box for some reason, and then out on a red with a light green wire. That's going to be a shared power for all of the coils, and then the PCM is going to supply a ground to each one individually to actually fire it. So what we're going to do is go up here to this connector C139 and put an amp clamp around this red with light green wire. Okay, here's our setup. Pico scope is here. Got an attenuator on channel 2. Channel 2 is hooked into the primary side of coil number 1. And then I've got an amp clamp around this red with light green wire. That should be our feed for all of our coils. There's that connector right there in front of the ECM. And we're going to go ahead and see what we get on the scope. I don't have any fancy screen recorders or anything set up yet. This is literally the first time I've ever used it. Okay, I've got to learn how to use the trigger, but I think this is going to give us what we need to know. Okay, this is fantastic. So you can already see the problem. The problem's right here. And I believe on the 5.4 Triton, the firing order is like 1-3. Gotta look it up. I think it's all odds and then all evens. Yeah, no, that's not exactly right. So the firing order on this truck is 1, 3, 7, 6, 5, 4, 8. So we can already see that we would expect to find a problem on cylinder number 3 because that's the one we're not seeing firing, and we definitely have the problem there. So let's see. Can we see any more detail there? I might have my clamp on backwards. So let's see. Cool. Alright, is there an option to invert a channel? Yeah, I guess I don't know how to do that. Alright, I'm not going to make you guys watch me learn how to use the Pico scope, so it doesn't really matter. Ah, man, battery life on this thing is horrible because I better plug it in or it's gonna die. Not fast enough, fella. Should have bought a new computer just for the Pico. Or maybe I just need to buy a new battery. This is the junk computer anyway. But I believe it's good enough for this. Okay guys, maybe we can finally get this to work. Computer battery died, camera battery died, screen recorder died. Alright, let's try this again. So we're going to zoom in. Hopefully we can figure out how to do it. On these two waveforms. So here is coil number 1. Here is coil number 3. Firing order is 1, 3, something. Doesn't matter. So here's your control voltage here on the primary side of the coil. The PCM pulls it down to ground 3 times for your multi-strike. And here is the current waveform for that coil. Now you see on the second and third strike here, you have a vertical line on the current. I believe that is because the magnetic field has not completely collapsed before the PCM starts trying to charge the coil up for the second and third strike. Now take a look over here at number 3, coil. See how we don't have that vertical line? I believe what that's going to indicate to us is that this coil is not building enough magnetic field, and then the field's actually completely collapsing before the PCM tries to command the second and third strike. So it's pretty cool. It shows us definitively that we have a problem with the number 3 coil, it also shows us that we don't have a problem with the ECM, and I don't suspect there's a crank input problem or anything like that, because the PCM is trying to turn that coil on. It's just the coil's not doing what it's supposed to do. So finally, at this point, I think we can swap the coil from cylinder number 3 to cylinder number 2 and see if all this nonsense moves along with it. When I took this out, it was full of water. It's been water down inside that spark plug well, no doubt about it. And then the spring's all rusty. So I don't know. I mean, I would think that's enough kVA. It could jump that, but I don't know that for sure. Alright, let's go ahead and put this in number 2. I marked it as bad.
At Grainger, we're for the ones who pay attention to every little detail. The ones who fuss, tinker, and sweat the small stuff. Because you know the tiniest thing can make the biggest difference when it comes to keeping business moving. We get it. We're the same way, offering access to product experts to help you quickly and easily find what you need. So whatever your industry, you know you're always getting professional-grade products. Call, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Let's see what happens. Well, crap. I fixed it. I got nothing now. 0, 0, 0, 0, 0, 0, 0, 0. I mean, it's still got some counts. I don't know how often this updates, but yeah. So I don't know, it must have been a bad connection between the coil and the plug. There was a bunch of crud down in the bottom of that spark plug well too. I blew that all out. So there's 1, 3, which now looks fine. 7. 2, which is where the bad coil now lives. Well, a few hours later, I make my way back to this truck. I think when we last left off, we had moved the coil from cylinder 3 up to cylinder number 2, and then our misfire went away. So at this point, I don't know what to think. Either the water inside that spark plug well was the problem, or the rust on the spring inside the coil boot. One of those two was the issue. I don't know. But it seems to be fine now. So I think at this point we should move away from the misfires and try to figure out what's going on with this timing issue, this P022. And then we have a P0345 camshaft position sensor. So you see we got a bunch of pending codes here too, which some of these I'm sure I set by unplugging things while it was running. So yeah, I don't know. I thought we had a coil F primary voltage or primary something. Ignition coil C primary fault. So that's cylinder number 3. So on Fords it's like A, B, C, D, E, F, G. That's A is 1, B is 2, C is 3. So ignition coil C primary circuit fault, that would be cylinder number 3. So I probably caused that. And then E and F would be what, 5 and 7. So that, I guess that makes sense. I unplugged all those cylinders. So okay, let's start it up, I guess, and see what's going on with these crankshaft or camshaft positions, and go from there. Supervision. Yep, don't screw up. Alright, since we got the Pico scope out and I don't see anything out of the ordinary on the scan tool as far as cam, advanced, retard, whatever, we're going to try to do a cam crank correlation with the scope. Worked.
Yeah.
And it looks like it's okay.
Yep.
All right, one more check I want to make. I want to do a manual oil pressure reading. So I just took the oil pressure switch out. It's in that housing there behind the oil filter. And I hooked up a actual oil pressure gauge. So fun fact about Ford trucks, basically since about 1985 or 86, they've all had fake oil pressure gauges. So it shows a gauge on the dash, but that gauge is just a switch. It doesn't tell you anything other than you have more than 7 psi of oil pressure. The engine's fully warmed up now. It still has 30 psi of oil pressure, and I've also put it in gear so that the RPMs drop a little bit. It doesn't go below 25, so I think we're okay on oil pressure. It runs fine. I don't feel a misfire at all. It just has that constant ticking sound. Even back here you can hear it. Well, if this is one of the overly dramatic hospital-based TV shows that my wife watches instead of a crappy internet video about fixing a truck, this is the point in the story where we would have our lab test results back and we'd be sitting down for a meeting with the family, telling them to prepare for the worst. So at this time, I think we should set the misfires aside and worry more about these timing codes. So we had a P022, camshaft over retarded on bank 2, and a P0345 for a loss of cam sensor signal. Now, again, I don't know what was done, if somebody unplugged the cam sensors or the VVT solenoids. I really don't know why we have these codes, but we have good cam signal on the scope. We have good cam timing. The waveform that we pulled matches exactly with known good waveforms that I was able to find for these 5.4 Triton engines. So I'm saying at this point the timing is good, the cam signal is good, at least at the sensor. And now I'm not checking it at the ECM. Guess we could be losing it somewhere in the harness. But this truck looks pretty clean. I kind of doubt it. We got good base oil pressure, but we have a ticking noise. And we also have a pretty severe rattle on startup. You know, it's got that timing chain slap. So probably the tensioners are blown out, but they're not bad enough to where it's caused a problem with the timing. So we got to worry mostly, I think, about this ticking noise right now. And I am leaning towards it being one of the cam phasers. So what happens in these Ford cam phasers, like any other VVT system, it uses oil pressure to basically retard the timing of the camshaft. And there's little slots inside the phaser that fill up with oil, and it moves a vane that basically rotates the sprocket in relation to the camshaft. And when they're at idle, so when the engine is idling, the camshaft is fully advanced, I believe, and there's a lock pin that's spring-loaded, and the lock pin should lock the two halves of the phaser together. And I believe that's the source of the noise on the phasers, is this lock pin. When it gets oil pressure from the VVT solenoid, it pushes the lock pin out and allows the thing to advance. So the reason I think that the cam phaser is the source of the noise and not, you know, like a cam follower or a lifter, or not lifter, a valve lash adjuster or the camshaft itself, is that the ticking noise goes away immediately when you hit the throttle. So as an experiment, what we can do is unplug the VVT solenoids and try hitting the throttle again and see if the noise remains. And I think that will definitively tell us that the problem is in the cam phaser. All right, in this test, both VVT solenoids are unplugged. Okay, now the same test with the VVT solenoids plugged in. Well, I really hope the camera picked that up. So when the VVT solenoids are unplugged, there is no oil in the cam phasers, and it relies on that lock pin to keep the two halves of the phaser locked together. And you can hear, I think, when you raise the RPM, that it still has that knocking sound. However, when you plug the VVT solenoids back in, as soon as you touch the pedal, it starts to retard the camshaft, and as soon as it applies oil to that phaser, that knocking, that ticking sound goes away. So after that test, I feel pretty confident that this truck needs cam phasers. And, you know, I don't know if that ticking noise would ever really hurt anything, but it is annoying. And if you want it to go away, I think the only way to do that would be to replace the phasers. Now, I don't know. Should we go ahead and replace the chains and guides and tensioners and all that crap while we're in there? I really don't know. I don't know, it's only got 119,000 miles on it, so that seems unlikely unless the actual guides have broken, which, you know, it's a Ford, so that's possible. Anyway, I think the next thing to do would be to talk to the customer. So there's a few other kind of odd things here too. I had a coil F primary secondary code. I didn't see anything on the Pico when we measured the current ramp on the coils. I didn't see anything pulling an odd amount of current. And then we had that P0171 lean on bank 1. I think that's probably just because of the coil 3, the cylinder 3 misfire. I believe it was shutting off the injector to cylinder number 3. Cylinder 3 is in bank 1, so I could certainly see that causing a lean code on bank 1. Anyway, that's where I'm at with it. Hey, kiddo, what are we doing? What are we working on?
Working on Thomas.
Yep, we got a little side project here. We got to fix Thomas. Green Krusties strike again. This little tiny DC motor. One of these little ears was all green and crusty. So I just cleaned it off. I think we're going to be able to fix them right up. Need about 8 hands to put this thing back together. Takes these special 3-sided screwdrivers too. Yep, we're working on Thomas. Okay, I need the top of Thomas. You're welcome. Yep, he sure does. Okay, you gotta remember not to put Thomas in the water, okay?
Okay.
Okay. Well, this truck doesn't look too bad underneath. All things considered, its age and being in Illinois, not bad at all. See, this drive shaft's pretty rusty. The weights are are popping off of that. And then what always happens with these box frame Fords is eventually the frame starts to go. So you see they put an extra plate on the inside of there, and then you just get that rust jacking and it puffs it out like that. Eventually it'll break the welds, and you know the story. Yeah, doing it on both sides of the transmission cross member there. It is leaking pretty bad. Something that's leaking pretty bad on the engine. Probably the valve cover gaskets, I think. See the AC compressor is all wet down there. The front brake pads are pretty well smoked. And then I noticed that looks like the rear axle seals are leaking. This side's not too bad, but this side must be blown right out. Pretty much leaking everywhere. Unless it's coming from the caliper. I don't know. I think that's, I don't know. I'm guessing that's an axle seal. Looks like somebody just put brakes on it. Clips aren't even rusty yet. Alright, I had a little chat with the customer. He told me that he still believes that the coils were supposed to have been replaced. Anyway, he tells me that the guy he bought it from, I guess he hasn't had this truck very long, the guy he bought it from thought it had a plugged catalytic converter, which is an interesting theory. So I think we should be able to see that on our fuel trims if I just kind of give her some gas here. It should go way rich, and it just doesn't really do that. Yeah, maybe a little bit there on bank 2, but yeah, I don't think so. Seems to drive fine. I mean, it's not a powerhouse, but it's only a 5.4. It's a pretty good sized truck. I just pulled over. It's missing again. Pretty bad. Now it's happy again. Man, that's crazy. Why would it do that? So it set codes for over retarded and over advanced on both banks. So do we have a VVT solenoid problem? Did I plug those back in? So I better check that first. Yeah, whatever it's doing, I just caught it. It's doing it right now. That was crazy. It was stuck at full retard or full advance. Why did it do that? I don't know. Well, this is the event right here. I don't know what to make of this. So look at what happens on bank 2. All of a sudden the advance just starts going up, 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 up from basically 0 to 63, and then the advance error is basically a mirror image of it. Why would it do that? It's like it tried to advance the cam and then it got stuck. Now look at bank 1. So bank 1, the actual advance is, you know, it's like plus or minus 2.5 degrees. But then it's showing us an error up to, I don't know how far this goes. It went off the scale. Up to 60, I'm guessing, degrees. So I don't know what to make of that. Seems to happen when I come to a stop after accelerating. So let's see if we can duplicate that. Yeah, right there. It's doing it right now. Why is it showing an error on bank 1? So the VVT solenoids are unplugged right now. Completely unplugged. And you see it's just going crazy. It's doing whatever it wants. And now it's fine again. Plug it back in. No change. This is weird.